When we look at the night sky, we see gaps between the stars. Modern physics reveals these gaps as a restless, bubbling ocean of energy. According to quantum field theory, the current consensus in physics, every fundamental particle in the universe is a ripple moving through invisible fields that fill all of space. We see this hidden architecture shape the physical world in plasma, the fourth state of matter. When electromagnetic forces act on plasma, it naturally self-organizes into twisting filaments, stable vortices, and highly complex structures. The background structure of empty space even exerts measurable physical force. In laboratory tests of the Casimir effect, two microscopic, uncharged metal plates placed in a vacuum will push or pull on each other, driven by the background fluctuations of space itself. Established science accepts that reality relies on a foundation of invisible, organizing fields. The mystery lies in how these fields bridge the gap between entirely different scales of physical reality. On human and planetary scales, classical physics sets the rules. This macroscopic world is deterministic, operating on strict binary states, like positive and negative, or 1 and 0. Zooming into the subatomic scale causes those strict classical rules to fall apart. In quantum mechanics, particles blur into clouds of probability. Through a property called superposition, they occupy a continuous blend of multiple states at once. These delicate quantum states are highly sensitive. Tiny environmental disturbances cause them to collapse out of their blended probability into a single fixed outcome. Because we lack a mathematical mechanism to connect the predictable forces of massive galaxies with the fragile probabilities of subatomic particles, the door remains open for grand hypotheses to try and unify everything under one framework. The theory of magnetivity suggests that reality is composed of a continuous, magnetic plasmatic substrate that organizes the universe through a single harmonic field. Elementary particles exist as stable, resonant vortices within a universal magnetic continuum. This reframes gravity as an emergent property. Differences in vibrational coherence naturally pull structures together. For entanglement, distant particles vibrating on the same harmonic frequency stay instantaneously linked by one continuous wave. This presents a view of the universe where the fragile probability of a quantum particle and the immense gravity of a star are simply different harmonic frequencies of the same underlying wave. The search for a unifying connective tissue is a long-standing tradition in theoretical physics. In the mid-20th century, physicist David Bohm proposed an implicate order, a deeper, hidden layer of reality from which all observable matter unfolds. Albert Einstein spent his last decades hunting for a unified field theory, attempting to weave electromagnetism and gravity into a single set of equations. Magnetivity shares conceptual goals with these iconic efforts. However, its specific reliance on magnetic plasmatic resonance means it remains a separate, unproven hypothesis. Mathematical elegance and philosophical beauty are not the same as scientific fact. True scientific acceptance requires a new theory to predict completely novel, observable phenomena that our current established laws simply cannot explain. This colorful heat map shows the cosmic microwave background, radiation left over from the early universe. Magnetivity must predict specific polarization signatures buried within this data that standard cosmological models miss. Deep space observations provide another test. The theory needs to predict unique anomalies in how massive galaxy clusters bend the light of distant stars, subtle, unique shifts that only a magnetic plasmatic substrate could produce. Without successfully deriving the rigorous, complex equations necessary to yield these specific laboratory and astronomical predictions, the theory cannot advance. The theory of magnetivity offers a lens to re-examine the universe, moving past binary limits toward a deeply interconnected reality. But claiming these connections as physical laws requires confirmation through empirical data.